We're being asked to take this equation and solve it for y. This problem is specifically a bit more complicated, or at least looks more complicated because of what's going on in the denominator with that m plus n. I'm going to do a similar problem here on the side just to highlight this. If I had c equals 4y over, let's just do a variable like x, how I would solve this is I would take care of the x by multiplying both sides by x. And what that would give me is, I'll write it just as a cx equals 4y. And on the right-hand side, why I would just get 4y is because this multiplication of x would cancel out this division of x. All right, so we do exactly the same thing actually over here in our equation. We're going to multiply just by whatever we're being divided with. And in this case, I'm going to multiply both sides of this equation by the m plus n. That multiplication of m plus n cancels out this division of m plus n. I'm going to reorganize this left side a little bit. Not that you have to, but I think it's easier to read. I'm going to write this as c times m plus n, which actually I could use distribution on, but there's no reason to. I'm not going to. Equals 4y now. That was the hard part. Now what I'm going to do is I'm just going to divide both sides by 4. Again, I do that to get rid of this multiplication by 4 here, and what I get is c times m plus n. Again, I'm using parentheses here, by the way, just so you know, because I'm treating this m plus n expression as one thing, and if I'm going to do that, which you can, actually at any time, you need to put it in parentheses like this. And to finish this, by the way, is there's this division by 4 that I took care of, and there it is. My equation has been solved for y.